lecture. This is going to be pretty short. We literally have like 2 slides left. And so we're going to talk a little bit about drugs, which you guys should have all gotten a preview of when we did our lab on Friday. And then we're just going to watch a few videos, and that's going to be it. So for the rest of the week, on Wednesday, we're going to have our review. I'll highlight what's really important for you guys to know for the exam, and then we'll have our exam on Friday. So I intend at some point this week to have an extra set of office hours. I like to do this before exams. I couldn't do that before the first exam because I was out of town. In the past, students have found those extra hours helpful. They can come in, they can ask about any questions they have. We can go over in detail whatever things you feel like you're struggling with. It's best if we can hold those after I've told you guys what you need to review, because then you have a better idea of what questions you're going to want to ask. So we're running subjects this week, so it's going to be a little hectic, and I don't have a good idea what my schedule looks like so far. But as soon as I know, I will post, and you guys can then either plan to come in or not plan to come in, depending on how you guys feel about the material. Does that sound good? Okay. All right, so there were a couple of really, really great questions on Friday. So I am going to take a couple minutes to answer those. I also have a couple of websites that I found with either articles or resources that also speak to those questions that you guys can take a look at. I'll post those after class. And so the first question that was really interesting was, what happens if you take cocaine and methamphetamine at the same time, right? So with cocaine, you have the blocking of the transporter, and with methamphetamine in particular, and other amphetamines as well, what you get is that you're actually having mass amounts of something pushed out and then reuptaken, right? And so what if, was the question, you're doing both of these, and essentially, even though you have dopamine being forced out, it can't actually come back in through the vesicle or through the transporter, right? And so it looks like, judging by this NIH article, some intelligent med student had asked this question before, and the general consensus and the general response was the idea is that you're going to get a heightened effect when you're taking both of those things at once, because even though you can't get the reuptake of the drug because cocaine is going to block, you're getting enough dopamine out there that it's still going to be stuck in the vesicles, right? So it's going to depend in part on timing, what you're taking first and things like that. But essentially, you're still, even though they're not doing the exact same thing, you're essentially getting a heightened response, and you're getting more dopamine in the synapse for longer. Does that make sense? It was a very interesting question. I hope that none of you are like, oh, interested in trying that, but they did note in the little article thing that it's not a good idea to do those separately, but certainly not to do them together because their effects are so similar. Many of the reported cases of these things, people doing these things at once, end in fatalities, right? So cautionary tale, don't do cocaine or methamphetamine, but certainly don't do them together. And then our second question was actually about ecstasy, which is not up here. And so we talked about ecstasy, which is also known as MDMA. We know that it has a similar effect to amphetamine in terms of what it's actually doing mechanically, but we know that it's acting on serotonin, right, instead of dopamine. And so the question that we had was, how long does this last, right? So because the serotonin reuptake receptor is damaged, so essentially what happens is instead of having serotonin going up back into the axon terminal, you have it being pulled out of the terminal and into the synaptic cleft through the transporter. So basically, the transporter is working in reverse, so sort of like a revolving door going backwards. What you see is that this tends to last 4 to 6 hours is the general consensus. The problem with this is at the end of your 4 to 6 hours of this working and it acting on that receptor in that manner, your serotonin is pretty much depleted, right? And so the article went on to talk about the idea that even if you, again, cautionary tale, I would not suggest doing any of these things, if you take one pill of ecstasy and then 8 hours later you take another, chances are it's not going to do anything for you because you've already depleted all of your serotonin. There's nothing left in your vesicles to actually give you that secondary high, right? And so the article then goes on to talk about things like repeated ecstasy use then contributing to depression because you're typically low then in serotonin chronically, you might say. Does that make sense? Okay, so that was a really excellent preview of all of these things. And so this is going to be a pretty typical review of the stuff that we worked through on Friday with our human neuron. So we're going to take a couple minutes to talk about serotonin reuptake inhibitors, and then we can kind of go from there. So SSRIs, so these are probably things that you guys have heard of before, right? So what are SSRIs typically used to treat?
Anxiety and depression.
Anxiety and depression, very good. So anxiety, because they also act on norepinephrine, right? This is your noradrenaline. And then depression, as we'll talk about when we get to the mood disorder chapter, serotonin is implicated pretty heavily in depression, though not by the means that you might actually suspect. And so an SSRI is meant to, it says it in the name, right? It's meant to inhibit the reuptake of serotonin. So what it's doing is it's keeping serotonin in the synapse for longer, and so you can get more binding of serotonin to the postsynaptic cell. And so we'll talk about this at length, but what you see with depression is not necessarily an imbalance of serotonin, but that you need more serotonin to have a neuroprotective effect on certain areas of the brain. And so that's not anything that you need to know about for this exam, but I think it helps with the understanding of what's happening here. So you need more serotonin in the brain so it can work to protect your brain from the effects of certain other chemicals. Does that make sense? Okay, so if you struggle on the exam to remember what an SSRI is doing, think about what the name is, right? It's inhibiting the reuptake, so you're getting serotonin in the synapse for longer. Right. All right, so cocaine, we did a practical demonstration of cocaine, and so we specifically use dopamine for our example, but it is important to note that cocaine actually will block serotonin and norepinephrine as well. And so another note with the comparison, not necessarily comparison, if you're taking both of these at once, so even if you weren't having as much of an effect on dopamine for the amphetamines, you're still going to get hits of serotonin and norepinephrine if you're doing both of these. So instead, if you're taking both, you're not just getting activation of your dopamine receptors, you're getting activation of serotonin and norepinephrine too. And so it's a very, very global effect that you would experience if you're taking both of those things at once. Again, not a good idea, right? All right, and so amphetamines, instead of just blocking the transporter like we see with cocaine, you actually get the amphetamines entering the cell through the transporter and then pushing all of the dopamine out of the vesicles. And so again, this is going to be where timing is important, so depending on what you're taking first, whether amphetamine can get in, et cetera, et cetera. But in part, or essentially the important thing for you guys to know, is it's coming in and it's pushing dopamine out of the vesicles. And so if you were to have to compare these, one's blocking, one is entering, and then pushing the neurotransmitter out. Does that make sense? All right. Oh, maybe. Is that true? No? Oh, this is so sad. My clicker might, let's see. Oh, it's low battery. Oh. I was like, oh no, my clicker died. It's seen me through so much. Okay. All right. So these are practical demonstrations of what you're getting here. So this is SSRI. This one's easy to talk about because it's right front and center. And so your SSRI here is blocking, this is your transporter, it's blocking that reabsorption, which is leaving all of this serotonin in the synapse to be taken up by the receptor sites, right? Over here we have amphetamines. And so you have your amphetamine going in through the dopamine transporter, and then it's coming in and pushing all of the dopamine out of the vesicles. Makes sense? That's exactly what we talked about. I think images can be helpful if you are a visual human. And then cocaine is up here, right? And so again, this example is using dopamine particularly. And so what you see is dopamine transporter is being blocked, so you have, again, a lot of dopamine left in the receptor to continue binding with a postsynaptic cell. Make sense? Perfect. All right, so that is it essentially for this. This is sort of a fun image for you that you can use when you're studying. So it has the little, you might call it like a little cheat box of what exactly these neurotransmitters are doing. You don't need to, like, I'm not going to ask you to draw the structures or anything like that. Remember, you will need to know the life cycle for at least one of these neurotransmitters, but again, that's stuff that we'll touch on tomorrow. Okay, any questions? All right, we're going to watch some videos now, and so for these guys, there's probably no reason to watch a video of a video, so signing off over here.